Alright, we're going to look at graphing a system of two equations and two unknowns by graphing. So I'm going to put one of the lines in right now, and that first equation is y equals negative 2x plus 7. That is in the form y equals mx plus b. Your m is your slope, that's your rise over your run. And then 0 comma b, that's your y-intercept, and that's where you're going to start. So for our particular problem over there, the negative 2 is the slope, so if we turn that into a fraction, that's negative 2 over 1. So we're going to go down 2 and right 1 for our slope. Our y-intercept is 0, 7, so we're going to start on the y-axis at 0 and 7. So we're going to write that information down. Okay, so our slope, we always make it a fraction, negative 2 over 1 if it's not already. And our y-intercept is 0, 7. So I'm going to go all the way up to 7. We'll put some more points in. Okay, and notice I go down. Down 2, right 1, down 2, right 1. Or if I want to go in reverse, I'd go left 1, up 2 to get those points using my slope. Okay, I think I'm going to put a little bit more in, all the way up to 9 and all the way down to 4 and negative 1. If I need to put more points in, I will. And I kind of have a tendency to not connect my dots when they're in y equals mx plus b until the very end, because then I can see where the two dots overlap, and that's going to be the point of intersection. So if we look at the other equation, y equals negative x plus 3, we have a negative in front of the x. It's always if there's nothing there, it's a 1, and because of the negative, it's a negative 1. So our slope is going to be negative 1 over 1. So we're going to go down 1, right 1, down 1, right 1, down 1, right 1. If we go reverse, we'd go up 1, left 1, up 1, left 1, up 1, left 1. Our y-intercept is going to be 0, 3, and that's where we're going to start. So I'm going to start at 0, 3, and I'm just going to go down 1, left 1. I'm sorry, not down 1, right. Down 1, right 1, down 1, right 1. So down 1, right 1, down 1, right 1, down 1, right 1, down 1. Oh, and that's where my two dots overlap. That's going to be my solution. And my solution there is going to be 4 and minus 1. I can check it real quickly in both of them to make sure that's true. In the first equation, so this point here is 4, negative 1. So the y would be negative 1. Is negative 1 equal to negative 2 times 4 plus 7? Well, negative 1 is equal to negative 8 plus 7, so that says that negative 1 equals negative 1. So it's okay in that one. In the other equation, y equals negative x plus 3, that would be negative 1 for the y equals negative, and then the x is 4 plus 3. So that's negative 1 equals negative 1. Also, so that is true in both equations. So we know that that is the point of intersection in our solution. The last thing I'm going to do is I'm just going to connect my dots, because they wanted us to do it by graphing. So we just put the dots in so we have less on the graph, and then so we'll connect our dots and label our lines. All right, our solution is 4, negative 1. We verified it. Goes through both lines, and we checked it in both equations. And draw our lines and label them. And that's all there is to solving the system of equation by graphing. Now, if they end up being on the same line, then we would just use one of the lines as our solution because they are the same line. If they end up being parallel, then it's no solution because they're never going to intersect.